Hello, welcome to today's lead code problem solving session. Today's problem is 945, minimum increment to make array unique. It's a medium problem, and let's read the problem statement. You are given an array nums. In one move, you can pick an index I, where I is within the bounds of the array, and increment nums I by 1, return the minimum number of moves to make every value in nums unique. Okay, so we can see that the uh, yeah, so we can see that the constraints are 10 to the power of 5 for both nums and the length of nums for each integer, right? Yeah, each integer between I, uh, yeah, within nums, the bounds are 10 to the power of 5, 10 to the power of 5. So rule of thumb can't go above like 10 to the power of 8. So at max, we can go n log n, and obviously seems like a sorting problem. Really interesting problem. I don't know how to solve this, so I'm gonna like try to come up with a few solutions. Like I can think of nothing as of now. Trying to think of like backtracking, but how do you change a specific integer? Like what number is kind of unknown. And like if I basically try a different value for every number, somehow we have to keep a track of all the numbers that have been covered from 1 to n, like 1 to n, yeah, 1 to n inclusive of n, and then we also have to check if we can increase a number or decrease a number and by how much. It's a lot, like each number has 10 to the power of 5 possibilities, and if we check for each number, it's going to be like 10 to the power of 10, and we have to check for like if we like backtrack for each number, like check once. If it doesn't come back, we come back and check again. And that's gonna be like 10 to the power of 5, power 10 to the power of 5. So it's gonna be like 10 to the power of 25, which is a big no-no. Yeah, this is definitely like a hard medium. Has a decent acceptance rate. I've seen worse, seen like very bad acceptance rates. So maybe there's something that I'm not able to like think of, some obvious solution in front of me. So let's see what changed here. 3 is 3, 2 is increased by 2, so that's 2 there. 1 is same, uh, 1's increased to like 5, so that's 4, and 7 stays 7. So that's 6 more, so yeah, we always don't know if we have to, if we can just increase the number or decrease it. And if we increase or something or decrease something, how much can we? Let's see if a sketchpad helps us create a new one. Let's say we have like 3, 3, 4, 5. I'm not sure. It's not obvious if I should like. I mean, when you look at it, it's kind of obvious that I should make this 2, but it's not obvious when you see it first whether you should like increase something or decrease something, because if you increase something, hmm, yeah, that's kind of what I have to like first solve, how to take care of the problem where I whether I have to increase something or decrease something, and then it kind of becomes obvious. Kind of thinking of like for each number, uh, you know, so if it's like 3 and 3, we try to like make this. Say we also have 2, we also have like 6, you know, uh, yeah. So we also have 2 here, also have 6. Now, we kind of keep a set, we kind of sort them here first. So we write this as 2, yeah, it's already sorted. So we check if 2 is there in the set, then we add 2 to the set, 3 to the set, and then we check for this 3. We can both decrease this and increase this. We first like decrease this, decrease this, decrease this. Even then, it's not a guaranteed solution. There'll be test cases where this will fail, and even if it fails, it would still take like 10 to the power of 5 squared. Just not good. Is there binary search in the loop somewhere? Yeah, what if for each digit we can just do like a binary search to check if that number exists? So like two, we start checking if one exists and all the three exist. Even then, so the question is for each value if does just using the closest non-existing value solve our problem? If that kind of solves the problem, we can build upon that. So like let's say for 2 years. Let's see the topics. Greedy, huh? Yeah, so I think the idea that taking the closest non-existing thing should work because that's what greedy means here. Mm, so let's do something. For nouns, let's sort it first. Let's take the main element, max element. Let's create a couple of queues, but the idea is to basically keep the elements which are below and over like a particular element we are trying to look into. Let's also use a counter. Right. Design one. Mm-hmm. Wait, let me just check something. Let's look at the docs. Open log clear power copy count. Yeah, there is count. And there's extend. Just looking for extend. So basically, I'm gonna put everything here, which is less than main element. Basically, for every number which is missing, how do I check? Keep a track of every element which is missing, which is greater than the main element. Like less than the max element. Yeah, this should be extend. Hmm. Create a set for nums. Now for element and nums, if we have the we continue. Else we do the magic now. And the magic basically is of Q. IQ. or this candidate. Now we'll use a result here. And basically give it the next element to high Q. Basically, I mean, give it the next element to maximum element. Excuse me. Yeah, let's do this max element plus 1. Do it here because I see that since that max element is already going to be in set, this is not going to be affected. Here also it's not going to be affected, not offended. Yeah, that's basically it. If there is no low Q, not high Q, basically do this part directly. Mm, I understand this is very bad code in general. Lots of continues, lots of repeated code, but I hope it gets the job done. Else you basically check, give it the closest core, like, mm, Yeah, let's do it a little bit different. There's too many cases that are being overlapped. There are like right a couple of more cases which will overlap. Gonna do it like a little different then. So basically, if not high Q, let's just pass it the max element again. So this can be like this. Basically, now we just check the closest difference. Yeah, hope this works. Hmm. Definitely not doing one thing right, which is Wrong answer, huh? Let's keep a track of what numbers we are adding to the set. Oh, oh, this should be 0. So we could just replace this with this. Sure, we can just replace this with this. Hmm. Okay. So it seems like we are adding like a lot of numbers. Yeah, way too many numbers. Or not. Yeah, we're still adding a lot of numbers. So, well, makes sense. We are writing continue here. What's this like running 4 times basically? I mean, we're not appending anything to nums anywhere. Okay. Debugging you have to do sometimes. Okay, where did 4 come from then? Hmm. It should just be 1, 2, 3, right? Where did 4 come from? Oh, okay. Track is definitely not the problem. Shop 1, let's print the result. Mhm. Oh, okay. Let's decrease it here. Let's make some random test cases. Hmm. So greedy doesn't work. Interesting. Nope. Just gonna pause the video. I think like I spent 47 minutes. I'm gonna pause the recording, look at the solutions, and come back and code because I don't wanna like show the editorial. Yeah, basically looked at the solution to realize that this is just increment and not decrement. Oh my god. I mean, it says in the title that it's just increment. Cool. So basically, you have to sort the numbers and 1 to like n. You basically check if the number is the same as the previous one. And if you basically check if nums I is nums I plus 1, I minus 1, if it is, you increase nums I by 1 and result by 1. One, two, three, and 2, increase 3, 3, 3 to 4. Thought we sorted this. Oh, we got like increase everything, even the next ones. So, and let's call this 0 to this 4, 4. Basically, I want this to like go to 2, right? And this is also 2. Take it to 3. Here, let me see the solution again. Or let's try to figure it out. I think I'll do at least that. The previous one, increase it by 1. 3, 4. Mm, yeah, I think this should work. Yes, this did work. Awesome. No, that name's good. Please see. Okay, this works. Hopefully, it passes all test cases. And it did. Great. Let's try this. What the hell is this? And log in. Wow. Wow. Absolutely incredible. Probably using ChatGPT to like guess, I guess. I mean, I don't know. Interesting. Awesome. I think we discovered some new features within LeetCode, but at the end of the day, we did solve it. I mean, with some help. So yeah, learned something new today that I cannot read. But yeah, thank you so much. Have a good day. Peace.